Hi, Hi, everyone, and welcome to today's webinar. We are going to be talking today on our 2024 drone accuracy study that our amazing team worked together today doing. We are joined today by myself, Diane Siri. I am the marketing campaign specialist here at Propeller. Been here for about a year and a half now. And we are joined here by Cam Bentley. He is originally from Trimble, comes from a very GIS heavy background, been with Propeller now for over 5 years, and definitely excited to have him on. And we are also welcomed by none other than John Walls. I know we've all seen him a couple times now this year throughout all of our webinars. He does come from a very heavy GIS background as well, and was actually the main writer of our current accuracy study. So John, if you could go ahead and push the slides forward for me. Love to go through that agenda for us today. We're going to talk through the purpose and the goals of why we did this accuracy report, as well as kind of go through our methodology, how we ran the test, as well as go over the results and some of the challenges and limitations with current drone surveying. And then we'll end with a quick Q&A at the end. So if you guys do have questions, don't forget to put them in the comments here, and we'll be sure to answer them here at the end. But without further ado, John and Cam, I kick it back over to you guys.
Perfect. Thank you, Diane, for the introduction, and Cam, thank you so much for joining today. As she mentioned, my name is John Walls. I'm a solution engineer here at Propeller. I was the main author, but there was a ton of people behind the report that we're going to be producing, the work we're going to showcase today. So from setting up the flights to QA/QCing the verbiage to processing the data. While I'm essentially kind of the tip of the spear, there's so much more behind me that made this possible. So a big shout out to the team for getting this report produced and verified to make sure that we're accurate. So Cam, introduction for you as well, sir.
Yeah, thanks, John. Happy to be here. Yeah, like Diane said, my name's Cam Bentley. I manage our key accounts team based out of Denver, Colorado. Been at Propeller for about 5.5 years now. Started as a solution engineer as well, just like you, John. So yeah, happy to be here. Excited to see the results of this report finally done and out in the public. So yeah, excited to chat about it.
Perfect. So what was the purpose of the report? What were the goals were we trying to achieve? And so when Propeller started, we initially produced a report in 2018 that verified the accuracy of the PPK workflow using AeroPoints and a Phantom 4 Pro. So in that time and over the last 6 years, the technology has greatly improved. We've got better drones. We've got better AeroPoints. We've dialed in our processing methodology. We've added Lidar support. So there's a lot of things that we've added over the last 6 years from a hardware perspective, a software perspective, that we want to go back and validate what we've been saying for the last 10 years is that Propeller is that gold standard for accurate drone surveys. So that was kind of the purpose of that. And then the goal was to replicate a workflow that our customers are using. So we're surveying an active job site. It's a larger site, about 100 acres. There's a lot of vertical relief in there. There's a lot of different things going on at that work site. So different site conditions, from asphalt, from open, grading operations. There's vertical structures that have gone in. There's vegetation. So it's all different mannerisms of site conditions. And so we wanted to replicate that work to show that we're going to get you accurate data even in a imperfect environment or your most common situations on the ground. So that was the main purpose and the goals we were trying to achieve. And again, we're talking about validating that claim of 1/10 of a foot or 3 centimeters on the X, Y, and Z. And so we've been saying it for quite a while. Again, for the last 10 years, that's been our claim, is using that the hardware, that software to produce that accurate data. So we also wanted to get validation from a third-party independent verification. So we did incorporate Manhart Consulting to come out, set control, and then did some analysis on the data as well. So it's not us that's only saying that we're 1/10 of a foot or better, but it's also someone else who can say that as well and provide that accuracy claim and really provide that justification that this is a solution that you can use in your suite of other options when you're doing surveying, tracking, monitoring, progress, things like that. So that was the main purpose and those goals that we were trying to achieve. However, we do know that accuracy requirements can mean different things for different phases of work or different industries. So Cam, if you want to kind of dive into this a bit more about what accuracy means for different companies.
Yeah, definitely. Yeah, and I think this is probably just an important thing to mention. Obviously, we work with a lot of different customers on a lot of different verticals, industries, etc. And what accuracy means to everybody is often different. So throughout the report today, and obviously what we're doing, we were testing empirically the accuracy of the surfaces that Propeller's data team will produce for our customers. And obviously we're always wanting to produce the most accurate data possible. But yeah, I just remember a lot of conversations over the years, even when I first started at Propeller, or even before Propeller, really nailing down what accurate means to specific people is important so that everyone's talking apples to apples. I remember having a conversation years ago with somebody who was on a coal mine, and what their definition of accuracy is very different than what accurate means to a survey manager on a civil project doing fine grading. So just making sure that everyone's speaking the same language in terms of what accurate means, I think is going to allow this conversation to go a little bit better. But yeah, obviously what Propeller does is produce as accurate of data as possible, whether it's Lidar or photogrammetry. So that's what largely today we'll talk about. And for the most part, what Propeller will try to put out in the world for our customers. But yeah, just when having conversations around accuracy, things like that, just making sure that everyone's on the same page of what that actually means sets a good stage for that conversation.
So to provide a little bit deeper clarity on what we're talking about there. So this is a civil construction project. And there's basically two facets when we're talking about what you can get from an accuracy perspective. So one, it's how you collect the data. How is your camera settings established? What flight conditions are you using? How much ground control are you using? How many checkpoints are you putting out there to validate that accuracy? So when we're talking about accuracy for this one, we're looking at that civil construction from that earthworks grading perspective, tracking that progress, monitoring work, checking against your grading plan. So that's the accuracy we're talking about. We're looking at that 1/10 of a foot, that 3 centimeters or better. So again, to Cam's point, if you're in the mining industry, you're maybe a little bit higher tolerance depending on what you're tracking. Same thing for landfills and aggregates, and maybe a slightly different requirement. There's also consideration for what's called global or absolute accuracy versus just internal or relative accuracy. So there's a lot of different meanings here. And again, what we're talking about is both of those things. So it's globally or absolute accuracy from survey to survey. So there's a lot of different ways that you can just define what accurate is, but we're kind of touching on both of those things, in that we're placing these models in the same place absolutely or globally every time, so that we're allowed to do the Propeller platform can then run those calculations, do that comparative analysis from survey to survey or from survey to a design file. So that's kind of what we're focusing on today. So again, what we wanted to answer is how accurate are AeroPoints. Again, the thing that got us off the ground, no pun intended, is the AeroPoint. It is that GNSS equipped ground control point, that smart ground control point that will go out on your site and provide a source of corrections instead of using an existing base station or logging into a public NTRIP or VRS network, an RTK network. How valid is the AeroPoint data that's coming back? How accurate is that for Lidar, for photogrammetry? And then how fast can you survey 100 acres using a drone, right? So we're talking about that speed accuracy paradox. Is this solved by using the AeroPoints and that PPK workflow in a drone? So is there a comparison between, I want to get fast data, but it may not be accurate, or to get accurate data, I need to do it over a long period of time. So using this PPK workflow, using this AeroPoint, you're going to get that accurate data, but you're going to get it back really quickly. And again, those real world questions we talked about. Again, we didn't fly a site that was meant specifically to return an accurate model. We wanted to fly a site that's most common with our customers' experience. and see what we got back from an accuracy perspective. We flew both missions. We flew a photogrammetry mission with the Mavic 3 Enterprise, and then the Lidar mission with Matrice 350 with the L2, the Zenmuse L2 model, and then process all of that with Propeller. And again, using that independent verification. So Manhard Consulting came out, established the control points, established the checkpoints. We processed the data. We sent them our deliverables. They did a verification of the accuracy, and we're going to look for that sign off from their PLS relatively quickly. And so let's talk about the Propeller workflow. So Cam, I know you've been here for quite a while. Where you're looking about 6 years now, 5 years, 6 years now.
Yep, 5.5.
5.5 years. So let's have you walk through what that PPK workflow looks like.
Yeah, sure. Yeah. First things first is going to be ground control. We obviously have our AeroPoint solutions, which you can see there in that step one. It's basically our smart ground control target. The new ones, the AeroPoint 2s that have been out for quite a while now, had some significant improvements over the first generation of those AeroPoints. So we now have an L1, L2 chip in that AeroPoint that's going to help us get all the satellite data that we need for our correction. So it's going to act as both a tie point that we can use during the photogrammetry processing, as well as almost like a static base station to provide that correction data to correct all the tags on the photos, ultimately giving us that very accurate surface at the end of the process. So step number one is laying out your AeroPoints or AeroPoints and a combination of traditional control. We do allow base customers to upload checkpoints as well. So you can indicate to us whether you're going to use those AeroPoints or ground control targets as checkpoints to validate the surface and the accuracy of that surface, or if we want to use it as ground control. But once you've laid out that AeroPoints per our team's recommendation and kind of best practices in terms of quantity and distribution, the next step is going to be actually executing that mission of the drone. So that's all going to be, depending on the drone you're using, it's going to be a little bit different. But by and large, it's a very similar process where you're going to choose the height that you want to fly at, the area that you're going to cover, overlap, camera settings, things like that. The drone will collect all of its data. Step 3 is where you come back to Propeller and upload that data to our team, where it's going to land on our data team's desk. Before we'll go through that data process, you'll get an email in your inbox when it's done that the surface has been generated, and you can jump right into your survey to access that. So yeah, the bulk of the work is done in step 1 and step 2 there, and then step 3 is where it comes back to our team.
Perfect. Yeah, it's a really simple process, essentially. So something that pretty much anybody can pick up and do pretty quickly. Now with Lidar, we talked about photogrammetry, where it's just place that AeroPoint out, fly the mission, upload the data. So we've been doing photogrammetry for 10 years here at Propeller. Over the last few years, Lidar has become a much more common workflow, been heavily requested by a lot of our customers. Now, there are several different reasons why you would fly Lidar, from inspection to just change analysis, change detection, things like that. Even things like methane detection you can use with Lidar. So having this conversation about Lidar, we figured that the best way that most of our customers are going to use Lidar is for pre-con flights, verifying existing ground conditions for the package, getting that topo through the vegetation as you're expanding on a mine, or as vegetation grows on a landfill. So incorporating Lidar was a really big priority for us because our customers were needing it. Those of you who may not know, Lidar can be a very complex tool. It's a very complex processing workflow. Data collection methodologies are going to vary fairly significantly from a photogrammetry workflow. But what we wanted to provide was essentially the same workflow that our customers are used to. Again, that 1, 2, 3 step: place your AeroPoints out, fly the mission, upload the data to us. And so that's what we've released in the last about the last year, is that support for Lidar, specifically for the Zenmuse L2 or the L1, where you just place your AeroPoints out there, fly the mission, and then upload the Lidar data. And we're going to classify that data. We're going to do all the denoising, the classification, the cleanup, and we're going to produce you the same suite of data from a Lidar data set that you're used to using in our photogrammetry model. So that's an orthophoto, a 3D terrain model, contours as well. So you're going to interact with that data in the same manner that someone's already familiar with using our photogrammetry workflow. So it's basically a plug and play situation. So the right conditions, we've gone through and tested this sensor at numerous different flight settings and camera settings and Lidar sensor settings to produce a really accurate model. Is it as accurate as photogrammetry? Not quite. And we'll get into that, the specifics of that a little bit later on. But we did want to showcase the validity of the workflow using Propeller's PPK workflow using Lidar as well, and to showcase that it is just as accurate, or it is just as easy and almost as accurate as photogrammetry. So for the methodology, I talked about this a little bit earlier. So it's a 100-acre site. Fiore and Sons very kindly gave us access to one of their canyons project. It's an active construction project. It's going to be new housing development, whole mixed use case over there. And there was about 150 feet of relief from one side to the other, from the north side to the south side. So a really big site. Again, a lot of things were going on, and that we did include that vegetation, that exposed dirt for the grading. There was already some roads that were poured in, so there's asphalt and concrete for curbs. There's two. The Cherry Creek Gulch Creek is flowing through here as well, so there's a lot of terrain there, a lot of terrain change, as well as that vegetation around those two streams. And then, of course, that built environment that we're looking at with the existing housings that were already there, and then there was new construction while we were on site. So again, just a really very common use case for our customers to fly that site and to get that survey done. Equipment that we used. So we took out 4 AeroPoints, and then we had them place 15 checkpoints down. Manhart put out 15 checkpoints, and we fly with the Mavic 3 Enterprise and that Matrice 350 with the Zenmuse L2. So a little bit more detail on that Mavic 3 Enterprise. It's been out for almost 2 years now, but 20.9 megapixel camera, an extremely fast shutter, longer battery life. So we're able to survey, larger sites in a single time with a single battery. We flew it at I can go over the settings later, but flew at 200 feet AGL, max speed, our recommended overlap settings. And again, we talked about that at the beginning, in that we've gone through these testing processes for all of these drones. And so the Mavic 3, the Zenmuse L2, we test these extensively. So that I'm going to shout out the data success team, the hardware support team, for running through multiple iterations of testing with different camera settings and sensor settings to make sure that we can produce that accurate model. And so we're using those recommended settings that we've established to fly this site. And so Steve Sheets from Manhart Consulting came out. This is walking through what that workflow looks like from a data collection perspective. Again, a lot of text here on the screen, and it can be rather cumbersome. And Cam, I think you made a good point that I want you to really dive into right now with that surveyor's workflow.
Yeah. I just think it's, again, something that's worth talking about. Obviously now in 2024, a lot of our customers are pretty deep in terms of the GPS technology that they are using. They have rovers, they have base stations, a lot have machine control, things like that. This is a perfect workflow if you have that equipment and you want to establish either supplemental ground control or additional checkpoints. Alternatively, if you don't, the AeroPoints can be used to create the same exact end result, which is very accurate coordinates that can then be used as either additional ground control to supplement the other ground control that you already have for the photogrammetry processing, or it can be used as a checkpoint. So we do allow you to indicate which points you want to use for ground control to actually be used during the actual processing, or have it be used as a checkpoint to validate the surface. So a lot of this can be skipped if you do have the AeroPoints. And you want to do it that way. If you already have invested in that GPS technology, most surveyors will be very across what this workflow looks like to set up that control as well.
Yeah, big time savings, of course, and that time savings does equate to dollars, right? So labor, there's also a safety issue, right? So while it took Steve around an hour and a half to go around the site and establish those benchmarks, those checkpoints, which, again, it's an active construction site. There's heavy equipment moving around. It's it's raw terrain, right? So there's a high potential for some sort of incident from happening. So it's lost dollars from lost labor because of a safety incident. So the implication of using the AeroPoint, one, you're reducing the amount of time out on this field, and then are also collecting that data in a much more safe manner. So yeah, good point, Cam. So flying that site again with photogrammetry and with Lidar, it took us about 20 minutes to fly both missions. We flew them separately. Got the data back. The photogrammetry returned in less than 9 hours. The Lidar took about 14 hours to process. So we got data back in less than 24 hours, which is a pretty common thing for most of our data sets here at Propeller. It does run through the full processing pipeline, managed by that team of geospatial engineers that are going to QA/QC that and make sure that there isn't any major shifts. So, and then the Lidar side of things, there's still a heavy mix of manual and automated processing with that. So there is some hands working on that data manually. So again, a fast turnaround time though for Lidar and really fast turnaround time for photogrammetry. And before I jump into this, there is a question that did come through, and just a reminder, if you do have any questions, please feel free to comment in the chat box. Cam and I will both see those. So feel free to send those in. I did want to address Pat's question right away because I think it's relevant to before we jump into this results and analysis. So Pat asked, does the report compare using AeroPoints for ground control checkpoint validation in the user's own processing workflow versus processing all of data by Propeller? So is there an implication here that your processing service will yield higher accuracy than a user could achieve using another processing workflow? Great question, Pat. And to be frank, it's not that Propeller is more accurate. We're just reducing that workflow for someone who's going to be processing data. So if you're self-processing in any number of photogrammetry solutions like Pix4D or AgTech or Trimble Business Center or any other solution that's out there on the market, if you're doing a PPK workflow and then processing the corrected images, you're now using maybe at least two solutions to correct the images and then process that data. If you're not a trained photogrammetrist, you may not have the knowledge to produce an accurate survey with varying conditions that the data was collected in. However, if you are well trained in that, then yes, you can still yield the same amount of accuracy. We're just giving you the option to offload that work and still get a accurate data set. So you're not strictly black box processing, and you're also not needing to use a second solution to tag your images. So it's just a reduction in the workflow. It's not that Propeller is more accurate. We're just easier. Cam, any additional comments that you'd like to add to that?
No, I think you've covered a lot of it. I think the important thing there is like our data team is probably our biggest team at Propeller now. So we do have a lot of folks who are trained in all of this. So if there is, for some reason, something that did come up that needs further troubleshooting, further deep dive into exactly figuring out what may have happened during the data collection process, our team is well suited to do all of that. And that's a lot of what Propeller service is having access to those folks who do have that deep understanding. So yeah, I think that's an important topic. I see Dan had a question as well about asking if we needed a base station with Propeller. We do not. If you are using a base station and you wanted to collect the data RTK rather than PPK, we can accept that data and just simply perform the photogrammetry, and we won't correct all the data since that's already been corrected via your base station. We can ingest that and just perform the photogrammetry. Far and away, the most common workflow our customers are working with is the PPK workflow. So the AeroPoint basically supplements that base station. So the AeroPoint will act as both the tie point and the static base station because of that L1, L2 receiver. And then we'll be able to use that data as our source of correction to correct all the other AeroPoints as well as all the images that the drone did collect during its mission. So we actually do not need that base station if you're using that AeroPoint.
Yeah, perfect. We'll get to some of those other questions here towards the end. But again, keep putting them in there. We got that Q&A session there at the end. So let's talk about the results of our flight. So with photogrammetry, we did two processes. One, we flew it with 4 AeroPoints and then our checkpoints. And then I reprocessed it again with 1 AeroPoint, because we've consistently said that 1 AeroPoint is good up to 100 acres. I always get a little hesitant when we say that, because redundancy is key. It's always nice to have some validation of the work. You can definitely go out there and fly with 1 AeroPoint. So we wanted to try that out to see, was there going to be much of a difference for 4 versus 1. So, and then with those additional checkpoints, we look in that here as well. So with our 4 AeroPoints, the 4 GCPs, the vertical difference to the 3D model, we're looking at just over 9 thousandths of a foot. So from a centimeter perspective, was it at just shy of a centimeter? So really tight model. And then the 4 AeroPoints, the checkpoints to the 3D model, we're looking at 500ths. So just shy of 600. So a centimeter and a half. So really, really tight model using those 4 AeroPoints. And again, we have that relief throughout that site. We still produce a really accurate model. We want to run it again with that 1 AeroPoint. So we ran it with 1. The 1 AeroPoint came back to, 1300ths of a foot. So again, not even a quarter of a centimeter. And then the checkpoints, this is where the real, I think the real benefit is. The checkpoints that we had out there on the site. And so on the right side, you can see the map where the checkpoints are and those ground control points. The checkpoints from that 3D model using the 1 AeroPoint, we still returned 400ths of a foot. So a centimeter and a half on the vertical. So again, a really accurate model, and again, perfectly suited for volume tracking. We're not going to be using this for asphalt builds or as builds, but this is wonderful for that earthworks tracking, grade checks to make sure that your elevations and your slopes are on point to design. So again, a really good job, and what I would say what we expected to see, but still just a nice number to see when we did process to make sure that it was dialed in, and we did validate that claim. It really helped quite a bit. Cam, any points you want to make on the photogrammetry side of things? Let me go back. I just gave away the Lidar answer, but we'll talk about the photogrammetry real quick.
Yeah, there's the picture. Is that a fairly standard, I think just for the general audience, is that a fairly standard distribution of AeroPoints for a site this size?
Yeah. So the first one we picked, so this known point, ground control point. So this is a locally calibrated site. So we did want to put the AeroPoint on one of the known points. The other 3, so ground control point 2, there's a slight ridge here in the middle. So you can see the road that comes up here. So we wanted to get the other side of that ridge. This is the low point, the lower point. We're sitting on the end of a ground control point 4 is at the low point. And then the ground control point 3 up here in the south side is towards the higher point. So we're covering pretty much all sides of the survey to make sure that we're dialed in and good coverage, right? So it doesn't have to necessarily be 4 corners, doesn't necessarily have to be the edges, but we've got a good mix of vertical relief and then those different just around the side of the project.
Awesome.
And yeah, the checkpoints. Yeah.
Sorry, John. I was just gonna say you had an important point there about it being a locally calibrated site in which we had a calibration. Maybe it's worth just quickly running over that workflow, because there's a lot of customers of ours, especially in the civil space, in the earthwork space, that are working in locals, and we'll take that calibration, but we also can support published coordinate systems as well. So maybe just worth quickly touching on how that looks and how that might be different.
Yeah, so a locally calibrated site, it's got its own origin point, so it's a local project grid. And so if you're flying a site that's going to have a design that's in that local grid, put the AeroPoint down on a point, or you can shoot it in with a base and rover, and then Propeller is going to process. We're going to ingest that calibration file from Trimble or TopCon, and so we're going to line up the photogrammetry results to that same calibration. So your design files are going to be a line up with the photogrammetry data, and we're going to use that multi-point calibration to georeference and rotate the model to that specific coordinate reference system. State plane, it's an easier workflow, if you will, and we're not going to touch on it in the in this webinar, but it will be in the report. We did process this same data set with 1 AeroPoint and 3 checkpoints from the other AeroPoints using Colorado State Plain Central. And the numbers are going to look nearly identical. So we can process both state plane, so maybe pre-con flight before the site's been calibrated, or during the progress where you can use that local grid. So really good, good point, Cam. We can support both of those, and we can support both equally well.
Yep, and it ties in well. I saw Wes had a couple questions in there about locals. So yeah, Wes, hopefully that addressed your questions. We can support either Trimble calibrations, GC3s from TopCon. Yeah, we can accommodate either of those. So yeah, thanks for clarifying that, John.
Yep. So that's the photogrammetry results. Again, I'd say what we expected to see, but still just a further proof that 1 AeroPoint can work on 100 acres. Again, a lot of things can go into play to how that's processed, but this is what we got from our specific results. Now for Lidar, there's 2 things to consider. So one, let's talk about what this looks like. So the 4 AeroPoints, the vertical errors that we saw were at 800s. So again, the vertical side of things is really tight on those 4 AeroPoints. The checkpoints were just were at 700ths of a foot. Now, our service level agreement at Propeller, when we're processing Lidar data, is 2 TITs or 6 centimeters overall. Now, the reason why that is due to the fact that we're doing a lot of that manual georeferencing of the model itself. So there is a bit more of an error, and just the Zenmuse L2 is great for this vertical data collection. If you're looking for a more horizontally accurate sensor, there are others on the market. You're going to pay a much higher price for those, but you can get more accurate horizontal data from other LiDAR sensors, but may not be necessary for these specific workflows. So we're focusing on those earthworks progress, the earthworks workflow. So those pre-con conditions through vegetation, getting that bare earth model. So vertically accurate is critical overall, or that total RMSE that we're seeing there, that 1400s, the 1100s, not quite as accurate as our photogrammetry model. We're going to be around that 2/10, but we're not as focused on that as much as we are the vertical side of things. So what we produce back from you from a LiDAR perspective. So what we're looking at here, this is the eastern side of the map that we saw earlier. There's again a lot of brush and scrub over there. So the orange that you're seeing, that's the classified bare earth model from that data set. So you upload the LiDAR data set. We're going to clean up the noise. We're going to do the strip alignment. We're then going to classify that point cloud into ground and not ground. We're going to take that ground classified point cloud and then produce a 3D model that our customers are used to working with. The other benefit of using that Zenmuse L2 is the Zenmuse also takes images, and it has the same RGB sensor as the Mavic 3 Enterprise. So we're going to take those images, we're going to create a rough ortho photo for you, and then drape it over the top of that 3D model. But to go back to the results, again, the vertical accuracy is going to be very, very tight. With 1 AeroPoint or with 4 AeroPoints. We did 4 AeroPoints. We got this really high number. 1 AeroPoint, we're also around 9/10, so really tight on the LiDAR as well. So that's the main crux of what we talk about with LiDAR and why it's important for our customers. Cam, I know you've got quite a few customers that are using that have jumped into the LiDAR situation right now. What's been the feedback? What are the use cases? Are they getting out of it what we expected them to get out of it from this solution?
Yeah, so I think given the amount of verticals that we are working within, the use cases do vary. But at the end of the day, it's exactly what you just said prior, which is an accurate ground topo. So we're not getting into all the different classifications that you can get into in other LiDAR processing solutions. We are after that kind of ground and non-ground classification. And the customers who have quickly adopted this are the customers who do need a good, accurate ground topo when there's vegetation present. Maybe there's a mining customer who's looking to expand their pit, and they maybe are starting a stripping project. They want to get a good topo before that stripping actually starts. That's been a pretty common example in the mining side of things. I think you put the nail on the head on the civil side, the civil space, with more on that pre-con topo or verify existing conditions. Go out there before you actually start the work, while there is vegetation present on the site, before you scrubbed it, get a good topo, use that to build your models, do whatever you have to do there. Then once you have scrubbed it, switch back to photogrammetry, where most of our customers are already licensed for it. It's a more accurate solution when it comes to that. So yeah, I think those are the good mixes there. But yeah, it's been interesting. It's been an interesting process to see. It's obviously we're only working with the L1, L2 receiver right now. So for the customers who already do have an M350, adding that sensor is much better than having to start from scratch with a new drone and new sensor. So customers with kind of that preset UAV option are the customers who quickly jumped in at the forefront.
Mm-hmm. Correct. Yeah. And there's the Lidar. I think it's interesting where Lidar is at in general, especially from a drone-based Lidar perspective. There's a lot of sensors on the market, and each one of those sensors, it's a proprietary workflow. So this is the analogy I kind of use most often is that if you're flying photogrammetry, you can pretty much use any software to process that data. You can use PIX, you can use Drone Deploy, you can use desktop solution like Trimble Business Center or AgTech or other cloud solutions. There's a bajillion of them on the market. They're essentially sensor agnostic, right? With Lidar, that's not the case. It's the complete opposite. So with every Lidar sensor, each of those sensors comes with a proprietary software to process that data. So when you buy that sensor, you're then pigeonholed on using that single software solution. So you maybe just be processing that I'm not going to call it any specific sensor, but you're using that very specific software to process the data. And then you're using a second software to do the analytics, to do the feature extraction, to do any sort of other number of workflows. So with the Zenmuse L2, the L1, Propeller is providing that single platform to process and analyze and create deliverables that can then be brought into a CAD solution if you're using it for model building. From that pre-con flight or the existing ground conditions, do you need to make design adjustments based on what you've been provided? So you can do that in CAD, but you're still just using that one solution to process and run those analytics. So with all those results, what does it mean? What does that mean? Again, we talked about at the beginning, accuracy has different meanings for different companies, for different workflows, for different needs. So what it does is the accuracy requirements we talk about, this sort of validates, it does validate our accuracy claims. You can get that survey grid accuracy of 1/10 of a foot, 3 centimeters, using that PPK workflow, that solution, and that processing. And again, you're tapping into that data success team. To reiterate Cam's point, the data success team here at Propeller is the largest department in the company. They are all trained photogrammetrists. There's trained LiDAR processing in there as well. So you're essentially hiring 75 people to process your data if you jump onto Propeller. And again, they're active 24/7. They're a very busy group of people. We're processing around 15,000 surveys. I think we processed over almost 16,000 last month. So again, there's a lot of gates and check to make sure that the data is accurate coming out of it. A really high point of pride. We do talk about data coming back in less than 24 hours or better. That's our service level agreement. From June of last year to June of this year, we produced over 100,000 surveys. It was 101,000 surveys, and 80% of those came back in less than 10 hours. So the turnaround time is extremely valuable, but it was also you're getting back that accurate data set as well. Confidence in that LiDAR processing. Again, if you haven't visualized what it takes to process LiDAR data, it's extremely cumbersome, very labor-intensive process. So there's a lot of nuance that goes into that. With our solution, we can still provide that same level of accuracy on the vertical, not so much the horizontal, but the vertical accuracy to the same degree. And then through those vegetated sites, produce that same level and then interact with that data in the same manner. But most importantly, the data collection and the processing side of things for our customers is the same as photogrammetry. Put your AeroPoint out there, fly it, give the data to us. We'll take care of it.
Yeah, I think that's probably, you hit on it in the first point, but the second point again, it's having everything in your, if you are in locals, it's everything's in the same system, whether it's Lidar, whether it's photogrammetry, you've imported your designs, everything's in the same project in Propeller. You have everything in the same spot. If you need to take it out to use it in Trimble Business Center, another CAD program, Civil 3D, whatnot, we do provide exports to take it out so you can do your work in another system, but you will have all this data in one place, which I think is really powerful once you do start getting into the different sensors, different data collection methods, Lidar, photogrammetry, even just importing a standard hand topo. You're just starting to have all sorts of survey data in one project in Propeller. Of course, the doors are open kind of both ways, but I think having the option for both in one place is going to help a lot of folks.
Yeah, to your point, there was a stat I was looking at last year that was talking about the amount of lost time because of siloed data. Different departments working on different platforms, or one department's working on version 2 when we're on version 4. And we're talking like millions of dollars of lost time looking for data or working on wrong data, because you have to then go back and rerun the analysis. Having everything in a central location, that single web-based platform that Propeller provides, cuts a lot of that out, right? We're de-siloing, we're breaking down all the walls to access that data. So just again, a much more efficient workflow after the data is processed. And so this kind of leans into this next point here, where we're simplifying and economizing the workflow. You're flying more often, you're surveying more frequently, you're doing progress topos weekly or twice a week as opposed to once a month, or maybe every the beginning, the middle, and the end of a project. So you're able to proactively respond to situations changing as opposed to reacting 4, 5, 6 weeks, even a month after the fact, or 2 months after the fact. So just really makes things a lot easier for you in terms of keeping track of that progress. And again, it's a much greatly reduced cost. And then working those jobs confidently and accurately, kind of just what I mentioned, is like you're bidding confidently, what's on the ground, where you are in relation to your grading plans, where you are in relation to your top of waste, your road designs, all of those things in there, that, as opposed to guessing what that is. And so that really another thing that we lean into is that don't guess, know where you are. It's really one of the great advantages to bringing drones on in general. I mean, we work at Propeller, so we're going to talk about Propeller, but just drones in general are just a much more efficient way to survey for your progress.
And I'll quickly jump back to the simplifies and economizes the workflows, because I think there are a handful of folks in the comments just asking questions about the AeroPoints and PPK workflow in general. You are able to use the AeroPoints as ground control if you are processing another solution. Obviously, we'd love if you were using Propeller, but we do have a small subscription that you can subscribe to for AeroPoint processing, where you can use your AeroPoints on site. We can correct that data. Ultimately, you'll get a CSV of those corrected coordinates that you can then use in your other processing solution for your ground control. Same goes for PPK. There was a question in there about PPK and having those corrections. So if you wanted to subscribe to that and have our team do the correction of the geotags using the AeroPoints as your correction source, we are able to do that as well. Ultimately, you get the same CSV of coordinates to use as ground control, as well as all the corrected tags that you can use for those photos in another solution. So yeah, if you are using Propeller to process the data all in one place, great, amazing. That's what most of our customers do. If you aren't, and you are looking for another processing solution, there are ways to take the data that we are producing and take it out. There's some differences, but by and large, it is possible.
Perfect. So to kind of economizes, I don't know if that's a real word, but we put it in there. So time is money, right? So we're talking about a 100-acre site. So let's just say that as the ballpark estimate. So just kind of break down the amount of time it's spent to prep the site, using photogrammetry. This is not including setting the checkpoints, but if you're just using a couple of AeroPoints, 30 minutes to set that up. Data collection time is 20 minutes. Processing time, 48 hours. Total manual labor, you're looking at less than an hour, and your total time is looking in that 5 to 9 hour range. Lidar, data collection, site prep is about the same. Data processing, again, a little bit more longer time frame on that. Your manual labor is still less than an hour, and you're still going to get that data back in less than 24 hours. Now, a walking topo, this is we're looking at this time frame as about as a 15-foot grid. So this can vary depending on the density of the points that you're putting in, but site prep about 15 minutes. Make sure there's, you get your base station set up with your rover, and then start collecting that data. So 100 acres on a 15-foot grid, you're looking at around 48 hours of manual labor time. So that could be, a two-man crew or a three-man crew working 2 to 3 days grand total. Processing time greatly reduced. You can probably do it less than an hour. There could be some QA QC that needs to be done, but that manual labor you're looking at is still 48 hours worth of time, and your turnaround time is going to be, that 42 to 2.5 days. So if you're doing a manual topo, a walking topo, and you get that data back, you're now 2 days behind looking at that data versus where you are on site, right? So if you're doing a civil construction project, you're 2 days removed from the data analysis versus the now actual conditions. So it's just really beneficial to try to get this to streamline the data collection as well as get that data back to you quickly, so you can make those answers or get to those answers much more efficiently. The final key takeaway, cost of drones have dropped significantly over the last 6 years. I think the Phantom 4 RTK, which is that first RTK-enabled survey-grade drone, we were looking around $9 grand for that out the door. So pretty expensive piece of hardware. The Matrice or the Mavic 3 Enterprise, you're looking at less than $5,000 for that. So has come down quite a bit. Lidar also has become much more affordable in the last few years. When I first jumped into GIS, was looking at Lidar, they were in the bare minimum was $25,000 and then up. We're down the L2 base model, or the L2 like MSRP is like just shy of 14,000. So price is reduced on that. Again, other sensors have reduced in price. The functionality has improved. The return rates have improved. So Lidar has become much more efficient, much more affordable as well. However, surveying is not, drone surveying is not the panacea for all things, right? So there are some limitations that we do want to discuss, because it's not, it's not meant for every single project. So it's not the end all be all. There could be sites where you're working in a restricted airspace. You could be, I know we have some aggregate customers that their sites are literally at the end of a runway at an airport. So it may not make sense to fly in some of those areas. You may be near a military base. You may be near a prison, right? All of those areas have heavily restricted airspace that you can't get a site up. So that's one consideration. Size of work site also, and that goes in both different directions. You may have a site that's, when we started talking about Lidar initially, we had some customers that were looking at, 2 square miles of area that they were looking to explore. And I'm like, there's no way that's efficient to use a drone for that. It's going to take you 5 or 6 days just to fly it. So, and then God knows how long it's going to take us to process that. So there's a sweet spot where you have to look at that. The other side is this, if it could be too small. So GNSS data, you need, 10 minutes to collect good data. You have to fly, enough time to get 10 minutes of flight time. So some of these sites may be too small, where it's going to be quicker. Just go out and take a few checkpoints with a base and rover and do it that way as well. So with weather, obviously it plays a big role into that. Drones are becoming better in higher wind conditions, better temperature ranges, but still, if you can't do a topo in the rain, you can't do a topo in the snow. Photogrammetry doesn't work well in fully covered, fully snowed environments. Water has a tendency to maybe throw the model off a bit, so you're not flying over a lake. That's where bathymetry comes into play. So there is a factor that plays into that as well. And then again, precision is another key factor. So if you're looking at a specific workflow for as-built on concrete or asphalt, you may have a less of a tolerance for accuracy for that specific thing. So you're looking at, I need millimeter level of accuracy for these for the survey. You're not going to use a drone for that. But we are the drone, the AeroPoint. It's a great tool to add into the surveyor's toolbox. It's just one more thing that you can use to make your job more efficient and not sacrifice that level of accuracy. Cam, anything to add there?
No, I think you nailed it. Yeah, I mean, I think at the end of the day, it's just a big surveyor toolbox. Rovers aren't going anywhere. Total stations aren't going anywhere. Mobile scanners aren't going anywhere. So a lot of this is just making sure that you do have a good understanding and education around what tools are available out there for different use cases, and then everyone can make their best educated decision. Yeah, photogrammetry is going to work great in a lot of cases. Vegetation is obviously the hard part there, and that's where you can substitute something like Lidar. If you're doing like a really, I don't know, if you're a PLS and you need to sign off on something and it's a small area, maybe you just go do a traditional hand topo. That's not going to change anyway either. So a lot of it is just making sure that you do have kind of a full toolbox, or at least the understanding of what's out there, so you can maybe look at what you can add to your toolbox in the future.
Yep. Perfect. Well, oh, hi, Diane.
Hi, I'm back. Hi, guys. Thank you guys so much for sharing that information. I just want to also say thanks, guys, so much for being so active in the comments this time around. We really appreciate all your questions. So with that being said, Cam and John, where do you guys want to start off on all these comments?
Let's see. We answered a handful at the front. Neil asked if this is going to be available for replay at some point later.
Yes, Diana, this will live here on LinkedIn and YouTube for you guys to review whenever you like. We'll also be sending you guys a recording directly to your email that was associated with the registration. So you guys will be getting that in the next 24 to 48 hours.
Perfect. Some folks asked about connecting with folks to talk about marketing or sales information. So I imagine that'll come from that email as well, Diane.
I'll definitely make sure to respond to that one directly.
Perfect. John, do you want to take some of the questions around the horizontal accuracy that you mentioned?
Yes, horizontal accuracy concern. Yeah, good question, Rob. And to address that, I think one of the things that we wanted to focus on at Propeller is that specific workflow using Lidar. So that specific workflow is producing that topo through vegetation, that bare earth model. Again, it's a very, I would say it's a very niche, but it's a very specific use case for Lidar in general. And we're focusing on those volumetric calculations between an existing ground file that was provided in a bid package, or just getting a better understanding of the topo through that vegetation. So the vertical, I think, for our customers' points, is a bit more important than the horizontal for that specific workflow. So again, as I mentioned, there are several different reasons why you would fly a Lidar mission that you would possibly need a higher accuracy horizontal model. You're more than likely not going to use the Zenmuse L2, and you may not be a Propeller customer. So if you're flying, if you're needing a higher degree of horizontal accuracy, in general, I would probably suggest photogrammetry be the solution, which that's going to tie you to a better accuracy of the X and Y. But if you're flying Lidar for horizontal reasons, you're probably using a solution that is not supported by Propeller. And then Chris asked, if Lidar horizontal is inaccurate, how can that be corrected for a takeoff of a vegetated site? Yeah, so we're not talking like gross inaccuracy. We're just talking about, 5 to 6 centimeters. So while it's not survey grade accurate on the horizontal, if you're looking at just that slightly larger discrepancy on the horizontal for that specific topo, our customers also don't think that the horizontal is going to be that much of a deterrent to process that data in another solution or get a different sensor. Cam, anything to add to that?
I don't think so. I think you covered it. I would just offer if Chris does have any further questions, he's welcome to reach out to either you or me, and we can have a call to discuss.
Yeah. And then Chris actually asked another question. With GCP and for AeroPoints, has it been used for as-builds? How can CEOR and DEQ have confidence in the accuracy?
I think a part of it is similar to the study itself, where a lot of customers will go out and they'll establish all the checkpoints that they think they need, whether it's for ASPRS standards or anything else. They can establish those checkpoints that will be kind of the best empirical check of the accuracy of the survey. We have customers who do this for just I don't know, mass grading, and their requirement for checkpoints is going to be a little bit different than an as-built. So it's certainly something that you could do if someone's willing to sign off on it at the end of the day. But you can establish as many checkpoints as you want, upload them to Propeller, and then that's going to be your best indication for empirically how accurate is the surface on the Z compared to those coordinates that were surveyed. And that could give you that sort of validation or information to make your best call. So yeah, a ton of customers do it that way. It's just a matter of ultimately how many of those checkpoints they need, depending on the standards they're trying to achieve.
Yeah, that's a great point. And we talk about pre-data collection validation of surveys. So to checkpoints is a great example. Another method we use is like basically post processing. If you want to validate that, we can export the 3D topo out of Propeller. You can bring it into a CAD program, or you can bring it into your collector and do elevation checks while you're out on site. We have a tool called Point of Interest, which gives you a northern, easing, and Z within that model. You can export those. You can put out as many checkpoints as you want within the model on Propeller itself. Export those out as a DXF, load it into your collector to revalidate the accuracy, the vertical accuracy and the horizontal accuracy of that model. So there's a lot of ways that we can validate the accuracy. Again, to Cam's point, just to reiterate that, you also want to check with whoever's signing off on that. What are they looking for? What are they looking for? Points in a specific setting? Are they looking in a specific location? What's the site condition they're wanting to check? That was one of the comments we got back from Manhard. He wanted to see a few more checkpoints on the asphalt. We had 5 out there. He wanted to see a few more, but they were still receptive to the model. So things like that will be used in consideration for validating that model. Let's see. Yep. So you already talked to Wes about the GC3 file. Steve asked about workflow for adding AeroPoints data to drone deploy. Again, I think Cam mentioned that, you're using the subscription, you're going to get a CSV, and then you would bring that into another solution. And that kind of goes back to Dub's point, is the data collected by the AeroPoints only accessible by Propeller and the software? Yes, there is no direct download from the AeroPoint to your laptop. You'd have to use the Propeller system to pull that data, that corrections data. Matt Kunish, is it the same process for mapping with the Wingtra Lidar drone? Yeah, great question. So Propeller does support for the full PPK solution from the Wingtra, their 24, their 42, and their 61 megapixel cameras. We do not currently have support for Wingtra Lidar. I think would be a great consideration over the next few months to get that ingested, because Wingtra is a great partner of ours. So we're looking on how we can get that software processing solution enmeshed with our current offering.
Amazing. Just taking a quick look, there are some very specific questions in here in regards to how you're specifically using the Propeller workflow. So I promise we will go into the comments here and comment, as well as reach out to you directly to make sure that you have the answers you need and that you're looking for. But really just want to thank John and Cam today for taking time out of their busy schedules to sit here and run us through this new accuracy report. If you guys hang around for 1 minute, I will be putting a link to the brand new accuracy report going live officially as soon as I click that button. So we really appreciate you guys taking time to sit here with us and listen to about our accuracy. And we look forward to having the conversation with you guys next month. Talk with you guys soon.
Thanks, everybody. Thanks, Diane. Thanks, Cam.
Yep.